Welcome to Chem 24 Lab, the synthesis of benzoyl amino acids. First, we'll take a look at the chemicals used. Start with benzoyl chloride on the left. Next to that, sodium hydroxide, 6 molar. Racemic DL-alanine. We have an ice bath, 12 molar HCl, diethyl ether, and our recrystallization solvents, ethanol water 1:1 and 95% ethanol. Next, we'll take a look at the equipment that we will use in this lab. From the microscale kit, we have a pipette syringe and a pear-shaped flask with cap. We have our pasture pipettes, a bunch of pH paper on a paper towel. We have our filter flask with a Hirsch funnel and small filter papers, along with a vacuum tubing. We also have our 10 milliliter Erlenmeyer, and we have a stirring device and then our heating device, so for our steam bath. We'll start by making a syringe pipette. In the syringe pipette, we take our syringe, which is scaled in 0.1 ml increments. We place a piece of Tygon tubing tightly over the end, making sure the Tygon tubing does not slip. It needs to be firmly placed onto the end so that no air leaks. And then we can insert a pasture pipette into the other end of the Tygon tubing, again making sure that there are no air leaks. It must fit tightly so that when we draw back on the syringe, we're able to pull a fairly precise amount of liquid into the pipette. Check the syringe plunger to see that it works and that there's no liquid in the syringe before we start. Now it's time to weigh the amino acid. First, we tear the weighing boat. There's the weight of the amino acid, DL-alanine, that we will be using. And we take that mass of DL-alanine and place it into our pear-shaped flask. And scrape it out to make sure all of the mass is transferred into the flask. Once it's all transferred into the flask, then we can add our solvents. First, we'll add our water, 1.6 milliliters. We'll take 2.8 milliliter increments from the syringe pipette using the deionized water. You can see that the solid doesn't completely dissolve initially. There's the second 0.8 milliliter portion. Once this portion of water has been added, we can add the sodium hydroxide. Normally it's not the correct practice to pipette directly from the bottle. It does look better on camera, so you know I'm adding the sodium hydroxide. In this case, we're adding 0.4 milliliters of the 6 molar sodium hydroxide. You'll notice when the hydroxide goes in, you see the mixing lines showing that the rest of the alanine mostly begins to dissolve. Then we place the cap with the Teflon side down and then screw it into place with the plastic cap, and then check to make sure that it's holding. And we can agitate it and shake up and dissolve the rest of our solid. To finish dissolving, we can put it on the shaker here. This will agitate the mixture without us having to shake it and turn it upside down. And then we're ready to add the benzoyl chloride. Again, with a syringe pipette, a fresh syringe, we're going to add 0.26 milliliters of benzoyl chloride, being careful not to over add it. Benzoyl chloride will be in slight excess, but if it's in too large of excess, we know that we get some unwanted impurities from the excess benzoyl chloride reacting in the aqueous solution. We also need to be careful to do this in a hood with goggles and gloves, as the benzoyl chloride is a strong lacrimator, very harmful to your eyes and skin. Then we replace the cap Teflon side down and make sure that the cap does not leak. You can see the oily droplets that sink to the bottom from the benzoyl chloride that doesn't dissolve in our solution.
Venting.
Checking that the cap is nicely sealed one more time.
Okay.
You can then bring it over to the stirrer, pressing down, get it to stir a little bit. This begins the reaction.
Okay, that's it.
At this point, we're ready to start checking the pH of the solution. Here's the pH key. We expect the pH to be basic initially, eventually turning acidic. So we see initially that we get this dark blue color, showing that pH is still quite basic. The reaction has still not gone very far forward. All the base we added seems to still mostly be in place. This image shows that the oily droplets still remain at the bottom of the flask. Eventually we continue shaking and notice then from left to right what's happening to the pH is the colors going from blue to green to yellow. This means that the reaction is releasing acid back into the solution and lowering the pH, neutralizing the base and any remaining amino acid. So now it's time to add more sodium hydroxide to our solution. The next increment is another 0.4 milliliters of the 6 molar sodium hydroxide, which we added once the pH was acidic or below 7. So we open the cap, add it in, and quickly cap it back up. Making sure the cap is in place properly, shaking the solution a little more. The solution has gone a little cloudy at this point. Most of the oil drops seem to be gone. At this point, the solution went back to acidic briefly. We added another 0.1 milliliters of base and finished the reaction with a clear solution and the blue color on our pH paper. At this point, it's time to prepare a cold HCl solution. We take some water, put it in a 30 milliliter beaker, about half a milliliter of water, put it on an ice bath, and add another 0.4 milliliters of the concentrated HCl. Again, normally you would not pipette right out of the container from the hood. We're going to add this to our water and then chill this solution so that we can prepare to pour our reaction onto this acidic solution. But remember, we ended up basic inside the reaction flask earlier.
Okay, pause it for a second.
Yeah. So once this is in an ice bath and stable, we take our reaction mixture and pour it onto the acid. Immediately you see a white, cloudy solution form. As you put the proton on all of the basic sites, it becomes less soluble in water and comes out of solution. Initially it was a very sticky product that only solidified on scratching with ice. In fact, at this point, you notice I broke the stirring rod while trying to scratch it. Scratching helps the crystals form rather than a liquid or oil that forms And you can see here eventually it did solidify enough for filtration. So once we have nice filterable solid, we can start our vacuum filtration process. A broken stirring rod. Make sure that the vacuum is on and that the filter flask is sealed tightly. You can see I made this harder on myself by not having a clamp that held the flask still while I pour. So I'm having to hold the filter down so it doesn't fall over, spill my product all over the hood. This way you're able to see the solid that's collecting on the filter. Nice white solid. There's quite a bit of it still left in the flask. I put the ether into the flask now. You add 1 milliliter of ether and pour it over the crystals to make sure that they are rinsed thoroughly with the ether. This helps to remove the benzoic acid byproduct that forms. And here you can see the rinsed crystals, fluffy white powder. You can see some after evaporation, there was some solid left in the filter flask. Presumably that would be benzoic acid. After pulling air through the crystals, letting them dry for probably half an hour or so, took the mass on the pre-tared weighing boat, then let them dry for several days and re-weighed them on the same weighing boat. You can see the mass had reduced as it dried. At this point, we're preparing the steam bath for recrystallization. So we place some water in a large beaker, some foil with some holes poked in it, and we turn on the heater to warm up the water. Then we transfer our crude crystals into our 10 milliliter Erlenmeyer for recrystallization. Usually we hold a little back just in case we get nothing from our recrystallization, so we'll hold a little bit back in the weighing boat, transferring the rest of them all into that 10 milliliter Erlenmeyer flask.
That's really good.
At this point, we add enough solvent to just barely cover the crystals. You can see I'm using 95% ethanol solvent to rinse out a little bit of the weighing boat after reserving a little bit to the side. And unfortunately, we were supposed to use the 1-to-1 ethanol water mixture, but I was using pure ethanol.
Is that covered?
And you'll see the result of this error, which I didn't catch until watching this video back several months later. So the technique is you add enough crystals to just barely cover the solid, just start to dissolve it at room temperature, and then you heat it up to its boiling point with a wood boiling stick to try and finish the dissolving process. This takes a lot of patience, just the right temperature. If the water is boiling too rapidly, you can overboil recrystallizing solvent. Here you can see there was still quite a bit of solid stuck on the side, and there was still some solid in the solution at the bottom. We didn't have terribly hot steam bath at this point. So now we're waiting for the solution to boil nicely. Once it seems to be starting to boil or get close to boiling, we can tell that the solid still has not completely dissolved. We wash it down the sides to try and get the material off the sides, and then I add a little more 95% ethanol. I should have added 1-to-1 ethanol water. So this is to finish the dissolving process. So at this point, the solution starts to clear up fairly well. You can see there's very little visible solid now. So we'll let it come back to a boil again. We added just a touch more there. Maybe it was a little bit cloudy.
5 drops of water. And kind of slightly cloudy today.
It's getting cloudy as you gather.
Just a few drops more. This is where it's key that you make sure you've dissolved everything in the solution. The instructions mention that if you should recrystallize if you have a colored impurities, but we almost never end up with a yellow solution at the end of this lab. So, but it's generally better to recrystallize it anyway to remove as much benzoic acid as possible into our final product, out of our final product.
I think it looks cloudy, right?
So once we're satisfied that we've gotten it all to dissolve, and we bring it back to a boil, then we know that we've gotten it as close as we can to that saturated solution at the boiling point. Unfortunately, in this case, due to the error, I used the solvent in which the substance was most soluble, and so it's going to be very difficult to get this material to come back out of the solution. This particular recrystallization is almost always troublesome, and I didn't notice on the day that this was a problem, that I had used the wrong solvent. And now that I look back at the video, I realize this is the reason I couldn't get it to come out of solution after this.
Yeah, that looks, I think.
It's just a slight bit cloudy.
Presumably, if I'd used the 1-to-1 ethanol water, I would have needed quite a bit more solvent to dissolve it, but it would have come back out of solution more easily. But again, the key at this stage is to dissolve it in the minimum amount of solvent at the boiling point, so that we get a nice clear solution at the boiling point, and we've only added a minimum amount of the recrystallizing solvent. If you add more than you need of the recrystallizing solvent, it will all dissolve, but it'll become even harder to take it out of solution.
Yeah.
It's good if I
So once we're satisfied that we've achieved that ideal state at the end of the heating period, we can take our flask off the heating source and let it cool to room temperature on its own, and hopefully crystals would form. But of course, in this case, we were fated not to have any crystals form. Every once in a while, you could see a little tiny piece of crystal here and there, but the crystals just would not form as it cooled down. Let it sit at room temperature for more than half an hour here, and just did not see much in the way of crystallization. At this point, I tried to scratch with a glass rod to try and induce crystallization. This can often act as a way to form some seed crystals. And you can see there's some solid that forms on the stirring rod as the solvent evaporates off of it. Put that back in, it can act as a seed crystal as well. But the solution never really took off in terms of crystallization. So after a long time waiting, decided to put it on an ice bath and start to scratch it. Once it was on the ice bath and cooled down, then we reached a point where the solubility eventually was low enough that the solution became supersaturated and eventually came out of solution. So you can see at this stage that there are significant crystals, but we had to put them on ice to get them to come out. They wouldn't come out at room temperature using the wrong solvent. Another issue is at this point, if I'd known I had used the wrong solvent, I would realize that the yield is going to be incredibly low. And I might save the filtrate, evaporate it, and then recrystallize it again from the correct solvent. But since I didn't know I had made that error during the filming, we're going to go ahead and let that finish crystallizing. Let it sit on the ice for probably 15-20 minutes and filter it. Okay, ready? So here you can see after a good long while on the ice, we do have a significant amount of crystals formed. This time I'll clamp the filter flask. I can pour the crystals out and then rinse them out of the flask, whatever's left, with a little more ice cold solvent. It should have been the 1-to-1. It's such a low yield and a microscale experiment. You really have to work hard to get every little piece of solid you can out of that flask.
It's a slight bit gummy, I think, is why it's doing that.
It often is.
And scrape every piece of equipment that you've had to come in contact with your solution, get those crystals off. And put a little more cold solvent just to rinse as much out as you possibly can. This is part of the fun of working on a micro scale, is that everything is at such small scale and it actually takes longer to get the crystals out than it would at a larger scale. So that last little rinse will serve as my wash of the crystals, and I'll let those air dry then for a little while on that Hirsch funnel, pulling air through to dry out the crystals. Take a look at the recrystallized product here. Get the right lighting. There we go. See, it's just a smattering of crystals across the bottom there. One thing that you can do to help them dry more effectively is to scrape them off the filter paper on the sides with a spatula to let more air go through them so they don't form a paste. So then you just carefully divide the crystals into small pieces and let air get pulled through them. Once we have our final crystals, we take our mass, only 43 milligrams of product. Take a melting point. There's the melting point right at the melting point, 159.5 to 161. So they were fairly pure, but we didn't get many of them. So thank you so much for watching, and we'll see you again in the next experiment.